Hi, I'm Judy. The topic I would like to discuss is 2016 house burglary versus surveillance cameras in Taipei City. Today I will go through my motivation, data I use, the models and results, and the conclusion. For my motivation, in 2015, Taipei City government released the data of location of house, vehicle, and bike burglaries. With this data, people have already created house burglary intensity map for public to know where the key area for a crime is. For the government, this data is also very useful. We can use data to formulate policies and lower the burglary rate. But if we only consider the intensity of burglary in a certain region, it may not tell all the truth, and may be biased because of more people living there or lots of other factors. I think surveillance system plays an important role of preventing crime and also breaking cases. Therefore, I would like to combine the Taipei City surveillance camera data with house burglary data to analyze. After getting Taipei surveillance camera data and do some data processing, I make a scatter plot with repeated times and number of surveillance cameras within 1 kilometer of each cases of house burglary in X and Y axis respectively. Each color stands for one district, and then we can see that different districts seem to have different trends. I use moving average to quickly show the trends of 3 certain districts so it will be more obviously. For example, Zhongshan district has an increasing trend, Neihu district has a flatter trend, and Shilin district increasing in the beginning and become lower and flat when repeated times over 20. Therefore, I think analyzing nearby surveillance camera versus repeated burglaries of different districts is quite interesting, and I will also do burglary rate prediction for the second part. Okay, so now quickly talk about the data I use. For nearby surveillance cameras versus repeated burglaries, I use burglary records from Taipei City government open data, which includes happening date, time, and address of the location. I transfer addresses to longitude and latitude so that it's easier for me to calculate the distance, and then I use them to count how many surveillance cameras and repeat burglaries in 2016 within 1 kilometer by distance metric (DISTM) from Geosphere package and for loop as the code showed on the PowerPoint. As for burglary rate prediction, I use the data of some factors that I think they may be related to the burglary rate, including surveillance camera density, police stations, disposable income, people with mid and low income, and average cameras within 1 kilometer of burglary location of each district. So next, let's go on the model I use and the results of these two parts. For the nearby surveillance cameras versus repeated burglaries, I separate all districts to see their trends. The lower left plot is the trend of Zhongshan district. Using precise, we can see the coefficient of all districts. Number 1 and 2 districts, Shilin and Datong, have negative trends, and Daoan has a flat trend. So what can this do? I think in most of time we expect that if one region repeatedly happen burglary, they should have more surveillance cameras. Therefore, for the police and the government, they can take a look of the solution rates of these 3 districts. If they are not high enough, but the same spot keep happening house burglary, it may be a time to set more cameras there. Then, after knowing the situation in different districts, I would also like to know whether we can predict house burglary rate with some key variables. I put the variables as I mentioned when introducing the data in the prediction model, such as camera density, number of police stations, and people with mid and low income and so on. And then make posterior validation check. It turns out that the prediction is quite well. The blue dots are observed burglary rates for each district, and the open points and the vertical black lines within them are the simulated samples with 89% interval. As we can see, most of the blue dots are in the 89% interval. Then we can set all variables by ourselves to get the prediction rate. In the lower part, they are coefficient of the model. We can see that camera density, which is number of total camera in that district divided by the area, people with mid and low income, and average disposable income negatively correlate the burglary rate. Number of police stations is positive correlated, and number of nearby cameras doesn't have much influence on district burglary rate. Okay, so I use Shiny to make conclusion. There are 3 parts, 3 tabs. The first one is burglary map. You can choose to show burglary location in red, surveillance camera locations in black, or both. After taking a look at the map, you can turn to the second and third tabs to see analysis result. The second tab is cameras within 1 kilometer. I make a scatter plot of all districts and you can choose any district you like on the left hand side to see the trend of that certain district. After analyzing, I found out that Shilin and Datong have negative trends and Da'an has flat trend. Others are positive. So maybe it's time for us to know more about the solution rate of these 3 districts and make some change. In the end, the third tab is for burglary rate prediction. You can set values for these 5 variables by yourselves and get a prediction rate. The prediction is quite good as you can see in the low plot posterior validation check. Hope you like all this. Thanks for your listening.